Assalamualaikum warahmatullahi wabarakatuh. My name is ILMAM BEJ41103 and it is under the DHIYA. So this is our project for digital communication. So we are from Group 5. Our group members is the AKMAL bin Ibrahim, the E1900064, Muhammad IZWAN HASHIM bin SYAMSYUL AMRI, CE2001007, me myself, Arif Iman BEJ411, the E2001004, Ahmad Akmal bin Ahmad BADRUDDIN, CE20045, and finally Muhammad Deni Putra bin SHAHRULLNIZAM, CE20025. So I'm gonna talk about the project background. So the project aims to address the fundamental facts that degrade the code performance in wireless communication system, differ, especially focusing on the time-varying nature of the channel and interference. These effects, such as multipath shadowing, and path loss, result in fluctuating signal-to-noise ratios at the receiver's output, leading to degradation in the system's bit error rate. The communication system diagram serves as a framework for the proposed techniques to reduce the bit error rate. MATLAB Simulink will be used to investigate and analyze the effectiveness of these techniques in improving the system's error performance. So that's all for me. Next, my friends will continue the discussion. Thank you.
Assalamualaikum and hello everyone. So my name is Muhammad Putra bin SHAHRULLNIZAM, metric number CE200225. So today I want to present about project digital communication and I'm from group 5. So this is my problem statement. This is the number one is variation, which are the consequence of multipath fading, shadowing and path loss cause an unstable signal to noise ratio, which is SNR, at the receiver. Now, second is the fluctuating SNR has a negative impact on the efficiency of the system, resulting to an increase in bit error rate (BER) and a decline in overall communication quality. And the third one is wireless communication system frequently operate in environments where multiple interference sources, such as other wireless device, neighboring network, and environmental noise are present. And the last one is this interference introduce extraneous signals that interfere with the intended communications, leading to a decrease in signal quality and an increase in bit error rate, which is BER. So we go to my scope project. My scope project is have five. So the number one is the project will involve identify and proposing suitable technique that have the potential to reduce the BER in wireless communication system. Second one is proposed technique will be implemented using MATLAB Simulink. MATLAB Simulink is a widely used simulation environment for system level design and analysis. The third one is this project will conduct appropriate investigation and analysis to evaluate the performance of the proposed techniques. Next, the main goal of the project is to demonstrate that the proposed technique effectively reduce the BER and improve the system error performance. And the last one is the project will include the validation and verifications of the proposed technique through rigorous testing and comparison. So the next will continue with my group mate. That's all for me. Thank you.
Okay, Assalamualaikum and hi. My name is Muhammad Hashim bin AMRI. So for my part, I will present about the block diagram and the system description. Okay, for the block diagram, we have information source, BPSK modulator, AWGN channel, BPSKD modulator and destination. Okay, for the first one, which is information source, it is the entity of systems that produces the information to be communicated. BPSK modulator, it converts binary data into a modulated signal by shifting the phase of a carrier. For AWGN channel, it simulates the effects of noise in practical communication systems. For BPSKD modulator, it compares the phase of the received signal with a reference carrier signal to determine the binary values. And lastly, for the destination, It is intended as the end or endpoint of the transmitted data. Okay, next is system description. Okay, to reduce the bit error rate BR in the systems, various techniques can be employed. First one is A. Error correction codes. Using error correction codes such as forward error correction (FEC), redundant information is added to the transmitted data. This allows the receivers to detect and correct errors introduced by the channel, thereby reducing the PER. Second is channel coding. Channel coding techniques like convolutional coding or Reed-Solomon coding can be employed to enhance the robustness of the transmitted signal against noise and interference. C. Equalizations. Equalization techniques can be applied to mitigate the effects of multiple threading and improve the signal quality at the receiver. D. Signal processing algorithms. Advanced signal processing algorithms can be used at the receiver to enhance the detection and decoding of the received signal, thereby reducing errors and improving BER. And lastly, modulation and coding schemes. Optimizing the choice of modulations and coding schemes based on the channel conditions and system requirements can also help in reducing the BER. Okay, for the next slide, I will pass to my friend. That's all for me. Thank you.
Assalamualaikum. My name is AKMAL. So now I'm going to explain about the manual calculation of a Smith chart to solve a matching problem in transmission line using a single step technique. So we'll start with the normalized impedance, which is the impedance right here. We are using ZL 200 minus J4 400. So to get YL, you run a line from ZL right here. We run a line straight through the origin, and we intersect it with the circle on the other side. So this point right here might be off if we compare it to the actual value, but so right here we have the R1 R equals to 1 circle. After we plot the R equals 1 circle, we find where it intersects with the R1 right here and circle. If we are dealing with impedance, the circle is called R equals 1, and if we are dealing with the admittance, it's usually called G equals 1, but in the end the circle stays the same. And right here we call this B prime. B prime is in the opposite of B, so A prime is in the A prime right here is in the opposite of A. So we do the exact same thing at the bottom, which we draw a line straight from the origin and to the origin. So another thing that we start here, right here, is that we start here from the load. So this is our, so we consider YL because remember it is in parallel. So this is our starting point. This is our starting point from any distance from the load. In the normal Smith chart, we start from ZL, but in this case, we start from YL. Okay, after plotting the value of DA plus DB, there's a law which says that it must be equal to the value or not. So the last part is the SWR on all segments. So, and how do we do this is by looking at this drawing. We're going to have let me show you the drawing here. This is the drawing. So by looking at this drawing, we're going to have a stub just right here, down here, and we're going to have a part that's going to the load, which is right here, and we're going to have an actual line, which is this, and line itself. So there are two SWR because there are three SWR because there are three interfaces, right? So SWR SWR1 right here is between line and the stub. So between the line and the stub, we should have a match condition. So this means S equals 1 from the calculation I wrote, S equals 1. So the whole purpose of the inserting the stub in the first place was to match the impedance. So by looking into the load to that of the line right. So next is SWR2, and next is SWR2 is a long stub, and this is going to be infinite because it's short circuited. And by short circuit, you will have full reflection, meaning SWR is infinite. Okay, now here is SWR3 is going to be between the stub and the load. This one we can just find it from reasoning by looking at the Smith's chart, and this is the intersection of the S circle and the real axis from looking at the Smith chart. So the result from the manual calculation from me. Thank you.
Okay, my name is AKMAL IBRAHIM. Now we go to the final output analysis. So this is the graph that we obtained from the BER analyzer. So the graph above shows the performance of digital communication system with and without Rayleigh fading technique. So the gold one is without Rayleigh fading technique. The purple one is with Rayleigh fading technique. So in terms of bit error rate, and also EV over N naught. So the graph also shows that the value of SNR for the system with Rayleigh fading technique is lower compared to the system without Rayleigh fading technique. This means that the system with Rayleigh fading technique is able to provide a higher quality of the received signal. So next, we're gonna see the scope block diagram for the system. So this is without Rayleigh fading effect, and this is with Rayleigh fading effect. So the figure above shows the different result from the scope of with and without Rayleigh fading effect. So the first waveform. So this is the waveform, the first waveform, and the last waveform is actually to indicate whether there is an error in the system. And the second waveform is BPSK modulation, and the third waveform is BPSK demodulation. So by looking at the scope block diagram for the system without Rayleigh fading effect, we can observe that the first and last waveform is have more disagreement than the plot diagram for the system with Rayleigh fading effect. So as we can see from here, the first and the last waveform have more disagreement, which is there's not the same. But when we look at the with Rayleigh fading effect, it's quite the same. The similarity is high than the without Rayleigh fading effect. So this means that the Rayleigh fading is still an effective method for reducing the error of the system, even if it is not able to eliminate all the error. So next we go to the discussion. So the Rayleigh fading effect reduce error in a digital communication system, although it might not eliminate all errors, but it shows a lower bit error rate and total error compared to a system without the technique. So and also the signal to noise ratio is lower in the system with the Rayleigh fading effect, indicating a slightly lower signal quality. But however, the technique is still effective in reducing error. So careful consideration is important when choosing error correction techniques based on the system parameter. And that's all from us. Thank you.